Okay, so here's a video of our Ionic versus Molecular Lab. We have three substances that we need to test. We have substance A, you can see right there. We have substance B, and we have substance C, okay? And our ultimate goal here is to determine which of these substances are ionic and which one of these are molecular, okay? So for our first test, we have to take a look at them through the spotting scope. And because it's really hard to do that through video, I'm going to insert some images of the results of that into this video at some point, okay? So we'll get a chance to see those that way. The second test that we do is a melting point test. So I've already preloaded up substance A, substance B, and substance C onto our hot plate, and I'm going to turn this on full power, and then we're just going to watch and see which ones melt and which ones do not, okay? Going back to our lab, we know that the lab tells us that once two have melted, we should stop because the third one will not melt in any usable time. So kind of pay attention here. So I am noticing already, if you took a look in the upper left-hand corner there, that B is already melting. So it looks like B is the one that melts first in our world. And then it looks to me, if you look right down, that A is now starting to melt also. So we see A is melting away fairly quickly also. And yep, A is now melted. And then we go over to C, and C is holding strong. So C does not melt between the two. So we'll turn the heat back off because that's all we had to do for that. So B melted first, A melted second, okay? And then our last test, if we come over here, is a conduction test. So what we have done over here, it's really hard to see in the video, but there's a solution in A solution in B, and a solution in C, okay? So we have dissolved the substances from here, A, B, and C, into water and created solutions, which are already in those wells there. We also have a well right below B that has just distilled water in it. So we're going to start by checking that and its conduction. So we put this in distilled water, and we notice that with the distilled water, we get a little bit of that red light to light up. See how that just changes just a little bit there? So even our distilled water has a little bit of ions in it that we can't get rid of, okay? So we make a note of that, because as I test A, B, and C, we're gonna get a little bit of conduction no matter what. So as long as we're only getting the red light to light up, that tells us that there's no new conduction because of the solution that's made. So let's start with A, and we'll place this in A. And same idea there, we're getting just a little bit of that red light to show, which tells us that this is basically conducting the same as distilled water, which we use to make the solution. So the compound A is not adding anything to the conduction. We move over to B, and with the same idea, where we're just getting that red light to light up inside of here. So we're getting no new conduction with B. So both A and B are causing no new electrical conduction. Then we come over to C, and whoa, there we go. So we see a major change in conduction for C. So both the red light and the green light coming on very strong, so we're showing a lot of conduction for C, okay? So from that, we can conclude that A and B, even though they dissolve in water, are non-conductors, where C was creating conduction.